is Adriana da Silva, and I would like to study how STEM project based learning can be used as an interdisciplinary approach while meeting the needs of teachers. So, the main focus of the study would be on the actual teachers. With the evolution of technology, there's been a need to better prepare our students for a world where science, technology, engineering, and mathematics, the STEM careers, how they have become more prevalent. In order to educate the students accordingly, teachers need to be well versed and have the necessary skills and competencies that will allow them to use a constructivist learning approach in the classroom. One such example is project based learning. Through many research studies, it is known that STEM PBL is an effective tool to use for teaching STEM concepts, but there are some skills that are needed in order to effectively execute the PBL, and these skills need to come from the teachers. Mahoney focused the research on two high schools, one with a STEM-based preparatory program and one that had a conventional or more traditional program. The researcher hypothesized that students in the STEM-based program would have more positive attitudes towards STEM, increasing how many of them will go into those types of careers. While the study focused solely on the students, further research could focus on observing which instructional strategies teachers used in the STEM-based program, which is sort of the focus of my study. Combining disciplines in the classroom can also enhance student learning. So it's not just learning about one specific subject, but combining across the disciplines and seeing that interdisciplinary nature of STEM. One of the qualities engineering students should have is the ability to work effectively as a team. This is one quality that can be accomplished through the use of project-based learning, and it can better prepare them for their future careers. While there is a vast amount of research that focuses on project-based learning in the mathematics and science classrooms, research is lacking for the high school engineering classroom. So there have been studies that have been made that work with engineering students in higher education programs, but not in the high school classroom. Gaps also exist involving the interdisciplinary nature of STEM PBL. So it's not just focusing on one of the subjects, but focusing on how those subjects work together in just one classroom. The focus shouldn't just be on students, however, when we talk about STEM PBL, that is the main focus that we usually see, and the outcomes, their learning outcomes. But the focus should also be on teachers and how they develop the curriculum, how they develop the project-based learning unit, and how they can effectively execute that PBL. Therefore, for this research proposal, the two research questions are: do high school teachers possess the necessary skills and competencies to execute a cross-curricular PBL in a STEM program? Because the high school that I work at actually does have a STEM program where the students will graduate with the certification in STEM. The second research question is: what can be done to support teachers to gain these skills and competencies? So again, the focus here is on the actual teachers. So because the high school that I work at is not a very big school and the STEM program is an even smaller program, the most appropriate methodology for this study is a case study because it's used for a small population or a group of participants. In this case, it involves two individuals, and an in-depth analysis can be done to collect different types of data, and it allows a better understanding of both teachers and their skills and needs. So to collect the data, first, the participants in the sample are the teachers for the STEAM health science focus because it's a STEAM program including the arts component versus a STEM program. So we have the health science focus, and the teacher is an anatomy and physiology teacher. And then there's also the engineering focus, and this is with the students in the engineering program that are taking engineering principles. So for collection of data, in this case, there will be interviews, observations, and documents that have all of the information. Knowledge is constructed in the interaction during the interview. A researcher can learn so much from speaking with the participants on a one-to-one basis. It provides the opportunity to understand the focus of the study from the point of view of the subject, which can actually provide a different aspect to the study and can even lead to more questions that can be answered through the study, or it can lead to questions for further research. Observation helps to understand the interactions of the participant in a natural setting. This means that I can go to the classroom with the teachers and understand and watch the skills that they have when interacting with their students and while executing the PBL. And all of this I'm doing using with all 5 of my senses, but I will be taking field notes and keeping these documents so that I can later obtain a different perspective and kind of see the where the two teachers interact, how they actually work together, and what skills and competencies and how I can better serve them. So while this research proposal will be a case study on how STEM PBL can affect cross-disciplinary team learning in a high school setting that has a STEM program, and the main focus is on the difficulties the teachers face. This study should be applied to a greater population of either whole programs or more schools with a similar preparatory program. So this can lead into future research because a case study can't really be used to determine what is the norm for a population. Case study can just give us an in-depth analysis of a specific setting, but this same case can be used for schools that are much larger, that have a larger STEM program, or schools that have it's just STEM program based. But it can definitely give a little bit of an introduction into how engineering students can work with other students from a different discipline in order to better inform themselves and work on these real life scenarios. Now, I wanted to add a little bit of background into what the project actually entails. So, the anatomy and physiology students, these are in the junior class, the 11th graders, they're working with the engineering students taking principles of engineering that are also 11th graders. Now, the benefit of these two groups of students working together, and it actually just worked out this way, is that they're going to be working together at the same time because the class is actually given at the same hour. So the students have the opportunity to actually collaborate. Now, one of the main parts about one of the main aspects of being an engineer is that they have to be able to work in a team. So one of the main concerns of this project is the students breaking the project apart like they normally would because they each want to take charge of a specific part, breaking the project apart and not collaborating. So through this project, because the fact that they're going to be working together in the same classroom, then the teachers need to have the skills necessary for the students to actually work together collaboratively. So they need to be engaged in the process, and the teachers need to be able to actually adjust their teaching so that they're not directly involved. From the preliminary findings, the teachers are more likely to lend a helping hand, and for project-based learning, they need to take a step back and allow themselves to be just coaches. So throughout this process, they need to learn about the different skills that they need to properly execute this so that the students are taking their own learning into their own hands. Now, the project-based learning portion of this is that it's a real life scenario where the anatomy students are kind of giving the engineering students a background, which is something that engineers usually have to work with. So they have to know if they're going to build something, where is this going to go? They have to understand the aspects behind it. So if they build a building outside, they need to understand the environment that goes along with it to be able to properly build it. So creating this real life scenario for the students is actually going to help them, help the engineers develop a little bit more of a collaborative working environment so that they understand how to work together. Now, the teachers, on the aspect of the teacher side, while the school does have a lot of project based learning information. They have a lot of professional development for this, and they do encourage the use of project based learning in the classroom. It is a little bit more difficult when it comes to the actual STEM program to get the students across the classes collaborating so that they understand that in STEM, the disciplines are very they intertwine, and it's not just science and technology and engineering and mathematics separately. They have to understand that these all work together, and that's something that the teachers also have to understand. Whereas the engineering teacher does take those things into consideration, but the rest of the STEM program doesn't highly involve any other disciplines. So, one of the key aspects of this study is going to be how they can actually produce all of this together. So, through observations of how the teachers interact with the students, allowing the students to fail and pick themselves back up again will be one of the more important factors to take into consideration when it comes to the necessary skills and competencies that teachers need in order to properly execute this cross disciplinary project based learning activity.